Today we're going to talk about protecting your belt. There's lots of components on a belt conveyor. One of the most expensive, if not the most expensive, and one of the most challenging components to service and to take care of is the belt itself. And there's a particular type of damage that Martin Engineering's talked about for many, many years. It's called entrapment damage. And it's grooves in the edges of the belts. And we're going to talk how to identify that, why that's problematic, and then how to prevent it. And at the end of today's webinar, I'm going to share with you some product innovations that you might find intriguing that might prevent some of the entrapment damages, depending on your reasons for entrapment damage, which you'll learn about. Some of these products may be useful for that. So stay tuned to the end to kind of learn a little bit more about that. As I mentioned earlier, we're talking today about entrapment damage. And entrapment damage is usually found either here or here on the belt. And it's just like what we talked about when we said grooves in the belt. Entrapment damage is usually when material gets trapped, and that's why we call it entrapment damage. It's usually when material gets trapped in between the skirt board and the belt and grooves the belt. But you're going to learn another way that that might happen. It's always found out on the outer parts of the belt, and where specifically it's found will kind of depend on where the material might sit or where whatever damage the belt might sit. It erodes the top cover of the belt with time and causes that belt to be problematic. So entrapment damage can be caused by cargo, or it can be caused by the material that you're conveying. It can also be caused by the liners or skirt board that you might be using to hold back the material. So we're going to talk a little bit about that towards the end on those liners. It can't be repaired. And that's one of the more problematic types of belt damage. Some belt damages that you might come about, they can be repaired. It can be costly, it can be challenging, and the repairs are never perfect. But entrapment damage really can't be repaired. There's really no way to reapply any type of top cover that's worn away from that belt. The biggest problem that I have with entrapment damage is, yeah, it causes the belt to fail prematurely, but in that process of complete failure of the belt, you're going to increase dust and carryback dramatically. When you've got grooves in the belt, belt cleaners don't make the proper contact with the belt that they need to in order to eliminate that carryback effectively. That's going to increase your carryback and increase your risk of worker injury from cleanup and your cleanup costs. If you have entrapment damage, you're also going to have a real challenge sealing dust if you're using some sort of skirting, rubber skirting, or urethane skirting to seal that air and spillage and dust in. When you've got entrapment damage, those seals just don't work as effectively. Now, one of the things that I always bring up when I talk about entrapment damage is the additional concern that you should have with entrapment damage when your belt mistracks a little bit. Lots of belts mistrack from time to time. It's tough to get them to run perfectly straight all the time. When you couple that little bit of mistracking along with whatever's causing this entrapment damage, you get some significant problems, and that's what you see in this photograph. So in this photograph, you're showing this worker with a 12-inch ruler showing how much the significance of a problem when that belt wanders a little bit along with something causing this entrapment damage. And the problem that you see is significant. You've got a major groove on the outside of the belt, really makes it a real challenge to clean that belt and a real challenge to seal dust and spillage. So it's really important to eliminate this entrapment damage, especially if you've got any bit of mistracking to the belt. So I've said for many, many years in our books and in our live classes and all of our webinars, we've talked for many years that entrapment damage is caused by the cargo that you're conveying. And that's pretty typical depending on the cargo. Now, some cargo, when it gets trapped, it will crush. But some, especially in hard rock mining, that material can get trapped and that can cause those grooves. So let's talk a little bit about this trapping of material. In the skirted area of the belt, like we've got diagrammed on the screen here, you can see if that belt sags a little bit between idlers, as that belt sags and travels on its path, and in this example, that's belt is traveling from your left to your right. As that belt travels in that direction, material is going to get trapped at that point right there with any belt sag. As that material gets trapped, the skirt board stays stationary, the roller stays stationary, and the piece of cargo stays stationary, but the belt continues to travel in its path forward. And with time, that piece of material that's trapped will groove that belt. So it's really, really important to prevent the sag that comes along with supporting belts in that skirt board. And that's what I've shown in this photograph here. If you look at the photograph on the right, you're going to see not the best practice on supporting the belt in the skirted area. In the photograph on the right, you see that these idlers are spaced what looks to be about maybe 20 inches apart, center on center. They might even be a little bit more than 24 inches. When you've got idlers spaced that far apart, you may not see much sag in the belt. In this photograph, you don't really see the belt physically sagging, but there can still get material to drop in that little bit of space that you may not see on the inside of that belt. So a better practice is to execute an idler arrangement like you see on the left-hand side. So on the left-hand side, these idlers are spaced very, very close together. And when idlers are much tighter in their spacing, you're going to eliminate that sag. You're going to eliminate that material getting in there, and that's going to reduce that typical entrapment damage. Idlers stacked very closely together aren't the only way that you can support the belt in the load zone to prevent that sag. You can also use cradles. And in this photograph that you see on the right, you're seeing a load zone with a cradle. And that cradle gives you some additional stability to the belt, and it also protects the belt from the material crashing down and damaging the surface of the belt. So the idea here of a cradle is to support the belt right here, eliminating any sag. And then you could stack an idler and use additional cradles. And this concept really should be used for the entire skirted area. Now, the advantage of doing this is twofold. One, it prevents entrapment damage. And the second is it's going to let your skirt system seal better against the belt because the belt's stable. So that's how we prevent material or cargo from causing this entrapment damage. Another way that you could cause entrapment damage is with your what we call wear liner. Now, wear liners are really important. Most facilities, most conveyors are going to utilize them, but they can be there can be some challenges with these that we're going to talk a little bit about. If you're not familiar with a wear liner, this photograph kind of demonstrates what it is. This piece is just typically mild steel, and that mild steel can be abraded from material very, very quickly, and it doesn't hold up. So what a lot of facilities will do is they'll use an additional piece of steel. Typically, it's on the inside of that mild steel, and that abrasive resistant steel used as a wear liner will hold up and last much, much longer, and that will let the skirting do its job much better. So that's kind of the intent of a wear liner. If you're not using that, you should. Wear liners protect that skirt board. It lets that skirt board really um, hold up and hold the auxiliary equipment, primarily skirting, in place. Wear liners allow dust seals or skirting to hold back air. Dust seals or skirting are not designed to hold back material. Their job is to hold back air. And if you hold back the air, you're going to hold back dust a lot better. So a wear liner's job is to hold back that material, letting that skirting or dust seal do its job much better. But wear liners have some unforeseen concerns that we're going to talk a little bit about. And one of the biggest unforeseen concerns is there's a reluctancy to put that wear liner really, really close to the belt. And that reluctancy is understood for many, many years in our books and in our classes. Martin Engineering's been teaching that that wear liner has to be really, really close to the belt in order for it to be effective. But most facilities have some reservations with doing that because they're concerned that that wear liner is going to get too close to the belt and groove the belt. And they should be concerned about that. That is problematic. You've got to have perfect installation to make sure that that belt doesn't elevate up into the wear liner and cause some damage. So that's kind of what we're dealing with, gang, and we're going to talk a little bit more about this and how to kind of prevent this. Okay, so there's risk to the belt when the wear liner's installed too closely. If you look at this photograph on the right, here's the wear liner, and you can see that that wear liner is installed really, really close to the belt. That's been professionally done by very experienced installers, and that's what you want to look for when you install an abrasive resistant steel wear liner in order for it to be effective. Now, when that wear liner is as close to the belt as what you see in the photograph on the left, that's going to allow this double-lipped skirting that you see on the outside. That's going to allow that double-lip skirting to work really, really well at sealing air and then subsequently sealing dust. But what you see on the left is pretty uncommon. The photograph on the right, far more common. And the photograph on the right, you're seeing, here's the mild steel, here's the wear liner, and you can see the gap between the belt and the wear liner. In this photograph, it might look to be about 2 inches. On this side, it's kind of tough to say, but maybe 1.5 inches, maybe 2 inches. And the reason for it to be that far off the belt is because this installation, there was concern that the belt would elevate up and make contact with that wear liner, causing grooves. Again, very legitimate concern. So what they're asking on this installation, if you look at this, the left-hand side, I'm sorry, the right-hand side, if you look at where the skirting now is installed on the outside, they're asking in this application, they're asking that skirting to hold back the material load, and that rubber skirting simply is not designed to do that. Its job is to hold back air, and you're going to have plenty of spillage in an application like you have on the right. There's also risk to the belt when you're using like ceramic tiles or something like that, because material could get trapped right here. If this belt's traveling this way and you got a piece of this material that got trapped underneath this, Then as it travels this way, that's going to cause that entrapment damage, and that's going to cause you some grooves in the belt that you're going to deal with. So the typical wear liners, although critically important to the success of sealing dust, sealing spillage, there's certainly some hesitations that we understand, and we're trying to guide you through. We're going to refer to some SEMA recommendations, as well as some recommendations from Martin Engineering's Foundations books. And this graph is a chart that I took directly from Martin Engineering Foundations books. And what this chart did for us in this book is to give us some different options on wear liner materials. And then it tells us whether that is not recommended, a good option, a very good option, or an excellent option. So for many, many years, we have recommended abrasion resistant steel. And the reason for that is because it's very good for temperature resistant, it's good for impact resistant, it's very good for abrasion resistant, and it doesn't have a significant cost. The problem with abrasion resistant plates is that you got to make sure that they're installed very, very close to the belt, and there's an unwillingness to do that for some. So, what we're talking about these days is converting over to a polyurethane wear liner. Now, there's a big advantage here to using a polyurethane wear liner. Some manufacturers will refer to it simply as urethane, but polyurethane is a slick plastic. Its sliding abrasion resistant is excellent, and its impact resistance is excellent. The concerns that we had for many, many years is that its initial cost was very high and the temperature resistant. If you're in a cement facility or you're running hot material, that urethane could melt and that could be problematic. But there's been some changes in how urethane has been made, and that's causing this recommendation. The initial cost for polyurethane has gone down radically. So the manufacturing process of urethane, the raw materials that goes into urethane have come down over the years. Manufacturers are able to make it more efficiently, and that's driven the price down and down and down and down. So when this evaluation was originally done about 10 years ago, polyurethane skirting was very expensive to install, but that's gone down considerably. The other thing is with some of the advancements in the manufacturing of polyurethane is that you can now get polyurethane that is heat resistant. So if you're running hot materials, it's really not problematic like it used to be. So that's no longer an issue, and that's no longer an issue, which really leaves us with polyurethane as an excellent option as a wear liner. Reason being is that it won't damage the belt, and you can put it right on the surface of the belt, just like you see in this photograph. So these are polyurethane slabs that have been installed on the inside of the skirt board. There's not material on the belt, as you can see, because this is right after the initial install, but you can see the gap between the belt and that urethane slab is just non-existent. Now, you don't want downward pressure. You don't want to pound that urethane slab or that urethane wire liner right down against the belt. You want to make sure it's just touching the belt. If you pound it down, you're going to cause some belt tracking problems because of pressure, uneven pressure, and you're going to cause some horsepower concerns as well. So it needs to touch the belt, but it just needs to sit on the belt and then be tightened down. Now, I want to show you this. This is a video I'm going to run. This is going to show you this. In this example, this is a urethane skirting. And this is actually high temp urethane. There's not material on this belt because this is just installed, but you can see the gap is very minimal. So it's going to seal material very well. And you can see as this belt runs, there's really no harm to the belt. So let's go ahead and try to roll this video. So there you can see that belt running. Now this urethane will hold up to much faster speeds than what you're seeing on there. That is as I mentioned before, it's a high performance urethane. It's heat resistant, but you can see how close it is to the belt. Just a couple of closing thoughts here on a polyurethane wear liner. Now here you see it kind of diagrammed. And remember when I talked about the serviceability. So this is a newer version compared to what I showed you in the photograph. This newer version has a T-bolt going through it. And that T-bolt makes it a little easier to service it. So those urethane liner can sit directly and should sit directly on the belt. It's a very forgiving installation, so you don't need these highly experienced installers like you might need for an abrasive resistant steel wear liner. It's lighter to handle. We don't talk about this enough, how difficult and how challenging it is to get the raw materials to the location to install. The stuff is much lighter and easier to handle. As I mentioned before, these T-bolts are really easy to make adjustments to it from the outside, from the skirt wall, or from the catwalk. It controls extreme fines without that added risk to the belt. Speeds, it holds up to 1,250 feet per minute. In the US, you're probably not going to see too many belts traveling faster than that. Internationally, just to do a quick conversion for you, that's 6.5 meters per second. There's going to be applications where internationally the speeds are going to be problematic for this stuff, but domestically here in the US, 1,200 feet per minute should be fine. As I mentioned earlier, the initial cost has decreased radically.